Hi everyone, this is our first video for chapter 2, and this is another type of graph that we haven't seen yet. It's going to be a quick video and then you guys are going to practice. So this is going to be in your day 1 chapter 2 files in the classwork section, and today we're going to talk about how to read, interpret, and compare time plots. So what is a time plot? So basically, anytime that data is collected over a time period, we can plot a variable, and this variable is a quantitative variable, which is a numeric variable, over time. So what we see here is it says that the time plot displays each observation against time, and notice that it says the horizontal scale, which is the x-axis, is going to be the time. So x-axis is the time, and the y-axis is whatever the variable of interest is, quantitative variable. Okay, so basically what they do is they plot a point for each time period, and then they connect the dots and they show a line graph. It looks like a line, and basically you're going to see some trends happening over time. Displays trends or change over time. Okay, so let's take a look at what I mean by that. So if you look down below here, you see this is the trend of Facebook stock. So some of you have phones that have a stock app on your phone, and if you click on that, you'll see something like this. It is a time plot, and in this case, there is an interval, a time interval on the x-axis from mid-2013 to September 2014. So if we look at our x-axis here, we see that it has the time. Okay, so the y-axis is whatever we're measuring. So it looks like we're measuring the value of the stock, which is numeric. And notice we're seeing some changes over time. So anytime we have to do with things like the stock market, usually what happens is in the short run, we have peaks and valleys. We have good days and bad. So you may see a dip here and there in the short term. But in the long run, we kind of want to look at what's happening over the entire interval. And what you may notice is if you connected from the first point to the last point, generally there's an upward trend or an increase in the value of the stock for Facebook. So it says up above for the directions, describe the trend that's happening over the interval. So we want to say there is an increase or an overall increase in value of the Facebook stock. And it looks like it's going from about $40-ish to about almost $80. So I'll say of almost $80. Almost, sorry, 80 minus 40 is 80 minus 40 is 40. So almost $40 over the time period. From November, it's a little before November 2013 to September 2014. Okay, so notice again, I'm using context. The context of the problem is the amount of money or the value of the stock. Notice I'm saying the word Facebook, and notice I'm specifically referring to the time period that is being measured here. Now we could talk about sometimes there's some dips, like from here to here, there was a dip, okay? And that might have been a bad period of time for the economy. Something went wrong. There was a war. There was a demand for fuel. Just something happened that caused the stock market to tank that day. There's all kinds of things that happen in life that can cause it to go down. But overall, in the short run, even though there are peaks and valleys, in the long run, we still see a general increase of approximately $40. So now down below we have a similar situation. They're talking about gas prices over time, and you know that the gas prices have really fluctuated and increased in the last few years. So here we see over the course of about 10-year period what's happening to the gas price. So hopefully you see that overall from the $1 mark to, and this one it was about 150, so it's a lot cheaper than it is now. There was an increase, even though there were a lot of steeper peaks and valleys, really sharp declines here. Overall, still there was an increase by about 50 cents. Overall, there was an increase of approximately 50 cents in gas prices over the 10-year period, with some drops in the intervals. So if I had to pick some of the biggest drops, I'd say there was one from here to here, one from here to here, and one from here to here. So maybe from 96 to 97, from like a little before 2002 to 2002, and maybe 2005-ish, like beginning of 2005 to 2005-ish. So I'll just say that, especially around 2005, there was a big drop. Okay. So remember when we're describing, it depends on the type of graph. When we talked about segmented bar graphs, we said one thing. When we talked about dot plots, stem plots, and histogram, we did SOCs. And this, we're not going to do SOCs. We're not going to do shape, outlier, center, spread. We're not going to describe it with skewed or symmetric. We are just going to talk about the overall trend that we see and if there are any peaks and valleys, and also what the total range is. So it looks like the total range was from the $1 mark to about the 150 mark-ish. There was a point where it did hit 170 also. Okay, moving on. So what might you see on the AP? So this was an AP question. And this is the caliber that you might see. So in this case, you see that there are two cities that they're discussing. They are Madison, Wisconsin, and Juneau, Alaska. And notice that they're labeled here and here. And it says that we're measuring the temperature in degrees Fahrenheit for the monthly average temperature in the two cities. So there are going to be some similarities and some differences. So think about Alaska and the temperature versus Wisconsin and the temperature. And it says, based on the graph, compare the two cities. So we need to use similarities and differences, which it says here and here. With respect to the monthly average temperatures, talk about some similarities and differences. Okay, so I want you to take a second here to think about what the similarities and differences are. And when you do, you're not doing it describing the shape, outlier, center, spread. You're more talking about the overall pattern. So take a minute, think about what might be a similarity, and then what might be a difference. Okay, so I'm hoping that you thought about the similarity is that they do start out at their lowest value in January, and then they increase to a peak in the middle of the year, like June, July, and then they dip back down again to their lowest in December. And that makes sense because seasonally, most of the time, there are winters where your temperatures are lower, and then they get higher, and then they get lower, okay? So that's the first thing we're going to say is there is an overall trend of lowest average monthly temp in January, reaching a peak of average monthly temp in June, July, which is the summer months, and then decreasing back down again to lows in average monthly temp in December. Okay, again, we should always put in context like average monthly temp. All right, now differences. I'm hoping you notice that there is more of a fluctuation or a range of temperatures in this top graph, which is Madison. So you may see that they reach a high of about 70 and they reach a low average monthly temp of about 15 degrees. So if you know anything about Wisconsin, you know that they get really cold winters, but then they also do experience summer. So you could find the range by doing about 70 minus 15, and you'll get 55 degrees, and that's going to be the range of temps over the average monthly temps for the year for Madison. And then you could similarly do the same thing for Juneau, and it's about like 55 to 20-ish, 55 to 22. So it's definitely a smaller range. So do we actually have to find the ranges of both? Same like before, we don't actually have to find the range in order to compare. We just have to compare them. So we want to say there is a greater range or variability or spread of average monthly temp for Madison compared to Juneau, which actually means that Juneau is a little bit more consistent with lower temps, and Madison reach higher and lower temps. They reach more extremes, okay? Because Alaska is just colder in general, and it's just colder all the time, even in the summer. Then the last thing that we can find is called the midline. So to find the midline, you guys learned this in Algebra 2. If you took Algebra 2 and trig, when you did the trig curves, the sine and the cosine curve, you learned about this. You could find the average of the maximum and the minimum. And that's going to be the midline or the median or the average, the mean. So if you do 70, which is the maximum for Madison, and you add that to the minimum, which is 20, and then you divide it by 2, you're going to get the average monthly temp, which is about 45. The average of the average monthly temp is 45-ish, okay? So that's like around here. And then let's do it for Juneau. Maximum plus minimum divided by 2. This is what we used to find our midline when we did our sine and our cosine graph. The maximum for Juneau is about 55. The minimum is about 20-ish as well. And if we do 55 plus 20 divided by 2, 75 divided by 2, help me out, people. It's about 37.5. Yes, I actually used my calculator for that. Okay, so basically what we can see, oh, I think I should change the Madison, by the way. The Madison bottom is maybe 15. So this should be 85 divided by 2. And that's actually going to be a little closer to the average temp. And the maximum was like maybe 75, but it's okay. All right, so like 42.5. So I'm hoping you notice that the average monthly temps are kind of similar. I'd say Madison's is a little higher because it does reach a higher peak. So maybe we could put that as a difference as well. So let's go down here. Madison overall has a greater average of average monthly temps than Juneau. That makes sense because you're not going to get any colder than Alaska, right? Okay, and it says for which of the two standard deviations is it greater? So I'm hoping you realize based on above that we said the range of Madison was greater. So Madison, because it has a greater range of monthly temps than Juneau. Juneau was more consistent, all right? So I'm going to drop the rubric for this in your folder for classwork as well. And then I want you guys to go on and try this next question, which was also an AP question. Please try it on your own. Thank you.